Hey guys, this is Samantha Young and I'm presenting Flipping the Classroom. So you may be asking yourself, what is a flipped classroom? Here's a quick video from the University of Texas that gives a great description of what it is in action.
Every course that has some face-to-face component progresses through a sequence of in-class time and out-of-class time. In a traditional lecture-based class, students are typically assigned material to study before coming to class, but then are expected to sit through a presentation that often covers similar content, and then assigned something to do for homework, usually on their own. In a flipped class, students have access to the instructor's lectures ahead of time, along with any other background material that they need, which frees up face-to-face time to let students seek clarification from instructors, collaborate with peers, and practice applying concepts while getting guidance and feedback directly from experts in the moment when it can help the most. This lets students leave class with an even greater collection of resources and a clearer awareness of what they need to focus on to close any gaps that remain in their learning. For more information on the flipped classroom and other teaching and learning resources, go to ctl.utexas.edu.
The beginnings of the flip model were started with Harvard professor Eric Maser, a physicist, back in the 1990s, who developed a model of peer instruction in which he provided material for students to prepare and reflect on before coming to class. And then they used class time to encourage deeper cognitive thinking through peer interaction and instructor challenge. As you may be aware, a lot of these physics classes at the college level in large universities are held in lecture halls, somewhere between 200 to 300 students in a class, which can make it very difficult for a teacher, professor, or an instructor to really interact with students on a deep level beyond just the foundational information that was typically given through the lecture model. This way, students can take the lecture home through a video format and then come to class with some background knowledge so that they can engage in those higher cognitive demand activities and interactions. So the theoretical basis for this model hinges in passive learning and active learning. The flipped classroom is divided into two separate things. So the first piece begins at home, where the student works by themselves, watching a pre-recorded lecture or video, and it's explicit instruction, that teacher-centered learning, that is direct teaching to the student. But the interesting thing about that is it can be adjusted, the pace, because the student can pause the video, rewind, and watch it as many times as he or she so desires. The student-centered learning aspect comes through the active learning that happens in the classroom once the pre-lecture or the out-of-classroom activity has occurred. So in the classroom, students are engaged in applying those new concepts and understandings. They are evaluating and analyzing those concepts and discussing things with their peers. They're synthesizing information to create resources or to create something. So this model definitely goes into many theoretical frameworks. The key elements to the flipped classroom model is exposure prior to class. Students need an incentive to prepare for class. There needs to be a way to check for their understanding and assess whether or not they are understanding that new information, and then the opportunity to engage in those higher level cognitive demand activities in class. So we'll begin with the opportunity to be exposed to the learning prior to class. This may be done through any form of video, lecture videos. There have been people who have used podcasts and any form of technology that provides some kind of way of learning, recordings, videos of any format. Students should be exposed to this content prior to class. And again, it can be done through a simple textbook reading even, but typically they're very short and they just give students enough information to gain a basic understanding of the content to be covered in more depth through those classroom activities. There must be an opportunity to provide some sort of incentive for students to prepare for class. It is very difficult to get students to want to do things outside of the classroom. So you definitely have to set this up in a way that promotes and encourages students to participate. Many times, these tasks are associated with exposure learning that can be offered for just points or in-class rewards, typically given just for completion rather than effort. And the goal is to encourage students to prepare for those in-class activities that will extend that pre-class learning. So the lack of background knowledge or foundational learning will prevent students from effectively engaging in those activities of higher cognitive demand. So encouraging them to do the pre-class work is important so that they can effectively participate in class. There needs to be a mechanism for assessing student understanding. I've given you a few examples here, but there are many. The internet has a wealth of free resources out there that are online quiz platforms such as Kahoot, Socrative, and Quizzes. It gives students instant feedback on their answer choices, and it can really help them to clear up their misunderstandings as well as focus that student attention on the areas with which they might be struggling. The data from these quizzes can also provide the teacher with information about where she may need to review or clarify the concepts prior to engaging in those higher cognitive demand tasks. So it may need to have a short review or maybe a short reteach of certain concepts before engaging in those deeper learning activities that are prepared for the class. And then finally, providing those in-class activities of high cognitive demand. Because students have gained a basic knowledge outside of class, they need to spend their class time deepening their learning and understanding while still attending to the standards and objectives of the course. Some examples of activities students may engage in during class that fall into high cognitive demand are debates, fishbowl discussions, experiments, data analysis, and synthesis activities. Of course, that list is not all encompassing. There are many things that students can do that really push their levels of cognitive demand. So what are the pros and cons of a flipped classroom? Well, some pros for are positive advantages of a flipped classroom where students have more control. They can make some decisions about when they do the work in their evening hours. So it gives them some more flexibility. It gives them an opportunity to, pause the lesson if they need to, if they need to take, small breaks in between the videos and the quizzes, or it just gives them some more flexibility. It promotes student-centered learning and collaboration. Once the pre-class videos are done and then students come to class to learn, there's more time to actually engage in student-centered learning and collaborative activities instead of a sit and get lecture. Lessons and the content are more accessible because a student can miss class but still get the videos and still be prepared for the next day's lesson because he or she has been able to access the videos at home. The access also makes it easier for parents to see what's going on and be able to support their child in the learning process. And of course, it can be more efficient because the pre-lecture is actually happening at home. Teachers have more class time to really engage in helping students deepen their understanding and broadening their conceptual understanding. Some negative things about the flipped classroom is that it can create or exacerbate a digital divide. And, I guess that can be debated, whether or not you feel that a 2 to 3 minute video every evening, maybe a 5 minute even video is going to really exacerbate that digital divide. But, it is creating, a more dependency on the digital media. There's a significant work on the front end on the teacher side. So the teacher has to do the legwork to find the lessons and or create the videos for the pre-lecture at home work that students would engage in. Again, flip homework, it's still homework, and sometimes it's difficult to motivate students to do that. And you also have to have the technology and the internet access, which can be a challenge for some students, especially in high poverty areas or schools where they don't have the one-to-one devices. Meeting the needs of diverse learners. Diverse learners in a flipped classroom can really benefit from this model. Rather than the standard classroom setup, which involves a teacher lecturing their students as a way of communicating material, a flipped classroom involves students in learning material on their own time and at their own pace. After they're first exposed to the content at home through those videos and audio recordings, then they go to class prepared to apply and synthesize the subject matter through active learning activities, like the use of case studies or in a medical setting or in a medical program or in group and individual work activities and any other kind of content area. With content that can be delivered through various media types, it better caters to various modes of learning. So students who have an auditory preference or a visual or a tactile preference, this mode of delivering information or delivering learning can really tap into all those different modalities. The flipped classroom can prove especially helpful for students whose first language is not English, or those who struggle with the pace of a traditional classroom. So by allowing students the autonomy to do the lesson at their own pace and get that foundational understanding at their own pace can truly set them up for success once they engage in those higher cognitive activities in the classroom. So what does it look like when applying this model to an actual lesson? This example is for a flipped college physics 2001 lesson. So before I show you the video, just want you to know the benefits for this particular format. So students can watch the video or take the quiz as many times as needed until they feel comfortable with the foundational concepts. Anyway, the class time can then be used to engage, of course, students in the problem solving and the clarification of those foundational concepts through the in-class demos.
Earlier, we looked at Newton's first law, or the law of inertia, and then Newton's second law, or F equals ma. And now we want to look at his last law of motion, or Newton's third law. Newton's third law deals with a fundamental characteristic of all forces, and that is that forces always come in pairs. Newton was first to realize there is no such thing as an isolated force, existing all by itself. Let's now state Newton's third law of motion. Whenever one object exerts a force on a second object, the second object exerts an oppositely directed force of equal magnitude on the first object. The third law is often referred to as the action-reaction law because it is often quoted as, for every action or force, there is an equal but opposite reaction. Let's see how we can apply Newton's third law to an action-reaction pair of forces between two objects and calculate their respective accelerations. Consider the figure below, where an astronaut pushes on a spacecraft with a force of plus p. According to Newton's third law, the spacecraft must push back on the astronaut with an equal but opposite force, or minus p. Suppose the mass of the spacecraft is 11,000 kilograms, and the mass of the astronaut is 92 kilograms. In addition, assume that the astronaut pushes with a force of p equals 36 newtons on the spacecraft. We want to find the acceleration of the astronaut and the spacecraft. Consistent with Newton's third law, when the astronaut applies a force of positive 36 newtons to the spacecraft applies a reaction force of minus 36 newtons to the astronaut. As a result, the spacecraft and astronaut accelerate in opposite directions. You might have initially thought that since the magnitudes of the two forces are equal, the accelerations of the two objects would be equal as well. However, that's not the case as the astronaut and spacecraft have different masses. According to Newton's second law, the astronaut will undergo a much larger acceleration than the spacecraft, since her mass is so much less. Using the second law, we calculate the accelerations to be equal to positive 0.0033 meters per second squared for the spacecraft and minus 0.39 meters per second squared for the astronaut. Even though the magnitude of the force on each object is the same, the acceleration of the spacecraft is much less due to its larger mass. We should note that each force in an action-reaction pair acts on a different object. So if we were to draw the free body diagram for the spacecraft, for example, only the force plus P would appear in the diagram and not minus P, which acts on the astronaut. Here we have shown an example using Newton's third law to analyze contact forces between two objects. However, the third law applies equally well for non-contact forces too, such as gravity. Imagine an astronaut in orbit around the Earth. The Earth exerts a force on the astronaut, pulling her toward the center of the Earth. And by Newton's third law, the astronaut pulls on the Earth with an equal but opposite force. We will learn more about the gravitational force in the next two sections.
So upon completion of the video, the student would then go to the quiz. So you can see how this game-like mechanism can definitely be motivating to students. But I'm just going to pick one so you can see what happens. Oop, got it wrong. See what it does? So it gives instant feedback for the student. The next question. Got it right. So you can see what happens. Again, giving that instantaneous feedback. It's got the game-like feature, so definitely students would find that entertaining and fun. We'll take a look at another lesson here. This is a flipped second grade math lesson. This is a Khan Academy video. Instead of showing it to you, I will link the original PowerPoint along with this video so that you can actually watch it. But the same kind of idea with the second grade math lesson. You know, sometimes maybe the supplemental materials may look a little bit different for the student. Maybe you're not going to link something in quizzes, but this could be for any level. Maybe it's a printed quiz. Maybe the quiz is linked through Google Forms and a Google Classroom. So there are many ways that a teacher can create an assessment. I've also done this where students watch the videos at home and then the quiz is given at the beginning of class. Especially with math, that's helpful. So it's not just memorization. I can really assess if they really have a solid foundation of that skill from the video from the previous evening. For example, it could be used in an art class with an art teacher who might want students to have an understanding of the primary colors for a lesson the next day. So the students would have a video that would be exposing them to learning the primary colors, and then in class they might do an activity with exploring with primary colors, maybe even mixing primary colors to see what happens when that's done. So I really think that the options are really limitless with this model. And that is all for my presentation. I hope you learned a little something about the flipped classroom model. I will definitely be linking the original PowerPoint so that you can take this at your own pace or use any of the resources that you'd like. Everyone have a great rest of the semester.